Hi everyone, welcome back to the workshop, and it's repair time again, and this time I've got something a little bit different. Well, certainly for me anyway. This is a digital multimeter. Well, I've repaired a few of them in the past, however this one's Polish. It was sent to me by a subscriber from Germany and asked if I would like to have a couple of faulty Polish test instruments. So of course I said yes. So we're going to try and repair today this Polish digital multimeter. It's a V560 made by the company Meratronik. Thanks to PCBWay for sponsoring this video. Their fast, reliable and high quality PCB fabrication and prototyping is essential for anyone in electronics. Add to that CNC machining, 3D printing, sheet metal fabrication and injection moulding, PCBWay can help you cover all aspects of your projects. Check out the link below to their website and all they can offer, including their online community for sharing designs. Now I do actually have the service manual for it, in Polish of course, but it does actually contain the schematics for it, so we're off to a good start despite the language barrier here. Now Kevin from Germany did say to me by email, and also as a little note on the top of the meter, greetings from Germany, the unit does not work, the soldering is a bit messed up on the top board, one red button's missing, this was my first repair attempt, I've failed. Well, we'll take a look at that, Kevin, and we'll see if we can effect the repair. Now it does actually come with a mains lead with, well, it's not a UK plug anyway, but looking round the back of it, you can see that we've got a mains on-off switch here. We've got a couple of fuses. I reckon that's probably the mains input fuse and probably for the current mode on the meter itself. And it looks like it's a fixed 220 volts 50 hertz. That'll be fine with the UK 230 240. And over at this side here we've got a current source 10 milliamps. Not really sure what that's about. I haven't printed out all of the service manual. It's a Polish company by the looks of it, Meratronik, but I'm not so sure that possibly the service manual is not in Polish but is in German. I've only printed out the schematics, but there's a lot of other information. Now one thing I'm not going to do is I'm not going to plug it in. I'm going to open it up first and take a look inside, because Kevin did say, as per the label on the top, he's tried to attempt to repair and failed. So I'd like to take a look and see what he's done, see if we can make good that repairs he was attempting before we actually power it up. Right, let's get the case off and take a look inside. And I think, does the bottom cover come off as well? Let's take a look. Let's turn it over. Yes, it does. Wow, there's some FR4 constructed shield by the looks of it there. Yeah, looks like we've got a grounding point there and one solder joint on the whole thing. Transformer there. Looks like we've got a TO3 package down there. We've definitely got some weird and wonderful components. Just look at that switch here. It's like semi-open with this weird cover. I'm not going to pull it off. And even the transformer there is not your normal method of constructing a laminated core there. And the PCB itself is definitely an 80s era looking construction. It just takes me right back to when we used to make our own PCBs. No silk screen, etching tank, developer tank, tinning tank, all the rest of it there. And it just looks identical to what we used to make. We've got two PCBs. That screen here is covering a second board that you'll see there, which is full size as well. So there's definitely quite a lot going on with this multimeter. But so far nothing's jumping out. I suspect we need to take off this top board here and turn it over and take a look at the other side. Now there is some evidence here that somebody's been soldering this IC here, and we've got some wire wrapping wire to affect some sort of repair. So first things first, let me take off the screws holding down this board and see if we can turn it over and take a look at the other side. Right. Oh. And here we go, and the first thing I'm noticing is this rather nice wiring loom coming off of this top board down onto the base unit there. And there's that IC that's had some rework, so somebody's put it in a socket, and there's another one at the other end of the board which is in a socket as well. But it doesn't look too bad. These ICs, I suspect a lot of them are 7.4 series, but there's no real evidence that they're the normal branding and from the normal manufacturers. So we're Poland making their own 7.4 series logic ICs. I don't recognise the manufacturer's logo on some of them. Yeah, but 7475, 7493, I suspect those are 7.4 series equivalents, but I could be wrong. And here is the bottom half of the unit. Looks like we've got much of the analog circuitry in the bottom half here. Those are the switches here, and a load of resistors across the switch contacts. A few potentiometers, presumably for calibration, and again this rather nice wiring loom. And here is the display board with its LEDs. There is some evidence here that somebody's been soldering a few light joints there, and maybe a repair or two, and a couple of transistors there, and a potentiometer as well. I wonder if that's for brightness or something like that. So the note did say that there was a bit of a repair attempt on this top board, which had gone a little bit wrong. So let's take a look over the board. Looks like we've got a bridge rectifier. We've got 4 large diodes at the back of the board. You can see the board slightly discoloured, but the diodes look okay, so I presume that's okay. And we've got a diode here that's floating way up in the air, so I wonder if that's the reference diode perhaps. There's a few op amps by the looks of it, 741 by the looks of it, so maybe this is the main reference diode. Exactly why it's on the top board I'm not too sure. That could have just been down to available space. But certainly this part of the board here looks like we've got a lot of digital circuitry, and that'll be for driving the display. So let's take a closer look at that repair attempt. I suspect that's where the problem is, and see if we can make it a little bit better or try to improve it before we power it up. Now the first thing I wanted to do was try and determine whether this is actually a through-hole plated board or not. And as you can see, we've got a bunch of vias, and I've pulled the solder out of this hole here just to take a look. And it is actually a through-hole plated via. So that's actually good news. It means I don't need to solder the top sides of these IC legs in order to make sure that we link top to bottom. Now the reason I thought it might not be a through-hole plated board is because all the vias are filled with solder, and that can be a way of linking top to bottom. Of course, back in the day we used track pins, special pins that we'd put through all the vias in order to link top and bottom, but as you can see, those don't exist on this board. It's just simply filled with solder. And taking a closer look at this one here, I've pulled the solder out of the hole, and it is actually through-hole plated. So it's slightly better circuit board than I originally thought. And here is this repair in question. Looks like a socket's been fitted to the board. It's not exactly level, but it's down far enough that at least the legs will go right through. So I'm going to just pull that IC out of the socket so that I can see down between the row of legs and inspect the tracks going off and on some of those pads. And what does concern me is that depending on how well the original IC had been pulled from the board, it may have ripped the through-hole plating, so I may need to solder the top sides. And luckily it's a turn pin socket that's been fitted, and the top side legs are exposed, so I can get a soldering iron in there. But also, if you look down here, looks like we've got some damage. There's a track that comes along here from this IC here, and it just stops. So, and I can see a sort of sticky mark on the board. It looks like it went away off to this pin of this IC here. So I wonder if that's what the links are on the other side of the board. Let's take a look. So it's linking this pin here to this pin here. And yes, that's exactly what it's doing. So that should be no problem. I've also got a link from here to here as well. Let's take a look at that one on the other side. And yep, we've got another track that's been pulled. So that'll be whoever took out the IC from the board didn't do it cleanly, and when they pulled the IC out, they ripped some tracks up. So definitely those through-hole plated holes will need reworked. So let me take the IC from the board. There it goes. Now I can't actually see too much, but there's not many of those top side pads that are linked on the inside side of those IC pins. Perhaps this one here I can definitely see. So yep, I will need to solder those top side pads. And a bit of a closer inspection here. This IC here, although it's not in a socket, it's definitely been resoldered, perhaps even removed at one point. So I'll need to take a close look at those top side pads as well. And there we go. I think that's that top side pads in the IC, or both of them actually, with solder on them. Right, that's the top side done, so I'm going to take a look at the bottom side now. The solder joints don't look too bad on the three ICs in question, but there's a load of flux etc. around this one here especially, so I'm going to get some IPA on the board and clean up those pins. And whilst I'm here, looking at these two solder joints here, very little solder on them going up onto the display board there, so I think I'll just resolder that too anyway. I'll leave the rest of them for the time being. Well, that's the top board about as far as I want to take it for the time being. So I'm going to take a look at the bottom side now, the bottom board. I'm going to take off that shield on the underside and just take a look at the soldering etc. on that bottom board, just in case. Oh no, it's actually a spring, which looks like it's to make contact with this large pad over here, which is basically covered in solder. So I'll need to check and make sure they are actually getting a good contact on that. And looks like we've got a label on the underside there. No idea what it says. 1.5mm, would that be the PCB thickness? And looking at the solder side of this bottom board, actually it all looks pretty good. There's a few soldered joints, perhaps a previous repair, something like that, especially around about here and over here, but the solder joints don't look too bad, to tell you the truth. I'm not seeing anything dodgy. You've got a link there of some sort. Now before I actually put power into it, I'm actually going to check the fuses in the back and check the integrity of the AC input. Make sure there's no shorts down to chassis or anything like that, or a low impedance between the live and neutral. Right, let's test the switch and the input circuitry, that transformer. So I'm in the off position here, so let's go across the plug. Yep, completely open, that's great. Put the switch to the on position. And yep, I'm seeing the primary on that transformer, 73 ohms. And then down to chassis. Oh, there's a... Yep. And the other side should be the same. Yeah, very high impedance there. That should be okay. 25 meg. And let's not forget the earth, because these 2-pin plugs, they're actually 3-pin. So let's just check it down to ground on the chassis. Yep, because I can actually see an earth wire there. So it's definitely 3 core. Yep, that's no problem there. Right, I think we're ready for a power up. Digital board's just lowered into place, no screws, and that shield is still off from the underside. But I think it'll be good enough for a power up. So the main switch is in the off position. And let's just switch it on. And yes, we got life. For a second there anyway. It looks like it's over-ranging. Of course, I don't have an input in at the moment. So let me put a short across those 2 terminals. And try that again. So, it looks like... yeah, we're definitely in voltage mode. It looks like I've got an AC switch here. Yeah, that's latched. Let's try it again. Little decimal points moving with the switches. Yeah, looks like we've got an over range on that voltage mode anyway. Let's just try ohms. Yeah. Yeah, definitely not feeling very well. Well, hopefully the previous owner didn't go nuts adjusting all the potentiometers on the board, because it could quite simply just be calibration, but I don't think so. Not the way this ohms is reacting. It's flashing between 0 and maybe over range, not too sure. Current. Current might be okay, but I would have thought there might have been some residual... nope, it's not. I was about to say I thought there might be some residual digits shown, but no, that one's all over the place as well. The first thing I'm going to do before I actually start looking at the schematics is just check the supply across those ICs. I'm expecting 5 volts, so that's the ground pin. If it's at normal 7.4 series logic, this should be 5 volts. And yes, it is. And it looks pretty stable as well. Well, off camera there, I had a little bit of a problem. I decided to deoxit the switches, these switches on the front panel here, and maybe try and clean them out in case there's any problem there that was causing the issue that we've got. And after I applied the deoxit, I found that the switches weren't working. As you can see, they're working pretty nicely now, but that's only because I've done something to re-enable them. Now, after I deoxited them and it stopped working, they were sticking, they weren't pressing, they weren't latching in, they were just a mess, really. I took some IPA, I've got it in an aerosol can, and I basically drowned the switches and let the IPA run right through the centre of the switches and out through the bottom of the meter, and it still didn't fix the problem. And the way these linked switches work, as you can see them here, is they're actually joined together, and there's a flat plate that runs right through from end to end. And when you press one switch, it shifts that plate in order to release one of the other buttons that may be pressed in. And for some reason, that plate there was sticking. Now, in order for that plate to work correctly, in conjunction with the push buttons, it needs to return to its start position. And it does that because down here there's a little copper coloured steel spring end on this switch here, and there's a tab in the middle there, and it's actually, it presses against the steel plate and pushes it towards the right. And what I found was that that plate there had lost some of its spring tension, because there is actually one on this side here for these other 4 switches, which looks to be in much better shape. So can you see how I got round the problem? Yep, I've gone ahead and just fitted a small spring between this bank and this bank. And that spring came from one of these. Yes, I opened up a pen, took out the small spring that every one of these types of pens have got, cut it in half, and it just fits in there rather nicely. Now I'll probably put some hot melt glue in order to keep it in place, because the switches are now working perfectly again. Now it's an odd shape, that spring clip there, that copper coloured steel spring, so it's not easy to go and make one or even find another one. Here it is. Perfect again. Now after cleaning out the switches, I have actually tried the meter again and it's still got exactly the same fault. So here we are with power on again, and I think I'll turn to the schematics now, because I do actually think the display drive is working. For the most part anyway, because I am getting some legible digits there, albeit it's flashing over range or whatever it's doing. Because sometimes when you switch it on, you do actually get some proper numbers. Yep, like 0400 there. Right, so here we are, ready to do some troubleshooting now. I've got the schematics to hand. I'll show you that in a second. So the first thing I think I'm going to look at is the ohms mode, the resistance mode. I've got the push button plugged in at the moment, and as you can see, display is upside down and it's flashing all over the place. And if I put in my shorting block here, let's plug it in, you see that it doesn't make a great deal of difference. So let's take a look at the diagrams. So this diagram here is not actually the schematic diagram, although it might look like one. It's actually a simplified diagram. So I've gone ahead and done a little bit of translation on some of the text, and it is actually titled the simplified diagram for the V560. So you can see over at the left hand side here we've got the DC AC current sub-range switch there, and that goes into a function block. You've got the voltage sub-range relay. Again, that comes into the same function block, and you've got an AC to DC converter here, which goes away off, the output of which goes away off into the same function block. The output from that function block then goes away up into this part of the circuitry here. I think we've got a little bit of protection up here, some back-to-back diodes made up a couple of transistors. That comes in through this, looks like an FET here, that's somehow being controlled into the analog op-amp circuit here. The output of which goes away off to QC. So that's your main output there, analog output, which covers all the different ranges of the meter. So I want to find QC on the main circuit diagram that I can then work backwards from. I think that's a good starting point. So this is the A to D circuit here, and you can see way off here I've got the same IC103 driving QC. So that matches up with the simplified diagram. So let's find that IC on the board, and let's do some measuring on that pin 9, I think it is there, and see if we're getting anything. But wait a minute. First things first, thou shalt check supplies. So I found what I think is the main power supply diagram for this multimeter. So let's take a look at it. Well, I've got the transformer over at the left hand side here. Looks like we've got 3 secondary windings there. And the first one here, its own bridge rectifier, that goes away off to this here. This is the 10 milliamp DC output that we saw on the rear panel of the meter. And it looks like it's just standalone, and all it's doing is providing a 10 milliamp output. It looks like you can configure it here or calibrate it. We've got some fixed resistors here, probably with some jumper links here to set it up maybe, and a potentiometer as well. So we'll ignore that one for the time being. The next winding down we've got some bridge rectifier, and it looks like we've got a 5 volt regulator here. Yep, 5 volt plus 5 volt, that'll be the main 5 volt for the logic. And down here on the final secondary winding, got a couple of diodes there, a couple of capacitors tied together, centre down to ground. That's a positive and negative supply, probably for the analog circuitry. So let's follow along this one here. Yep, that's the positive side of this op-amp here, the 741, and the other side here, the negative side. Yep, the negative side. Moving down here, looks like we've got another power supply circuit here, regulator circuit, because we've got the unregulated coming in. Looks like via these op amps and these series transistors here, and a few resistors, diodes, etc. Looks like we've got the generation of a positive and negative supply. Probably goes away off to most of the analog circuit. And over here, I wasn't sure what this was doing when I first looked at it. I thought at first it was maybe a programmable current source, because we've got these 5 inputs here coming into the base of these 5 transistors, and they're all set up with identical resistor values right along it. So I was thinking, and I thought maybe if you control the bases you could add up the current. However, when you look a little bit closer, the collectors of each transistor are kept separate. It's not as if they're tied together in order to do that. So I just think this is just doing some sort of level switching here. But funnily, when you look at the idents here along the top, QN positive, Q0, Q5, QA and QX, they're labelled identically down here. It's a little bit odd. I'm sure that would cause some sort of confusion right around the circuit. The only one that's a little bit different maybe is this one here. The collector goes away off, a series diode in this circuit here, and you've got the QN positive down here. A little bit odd. But first things first, let's just check that we're getting the 5 volts, and let's have a look at this circuit here on the actual meter and see if we can measure what sort of voltages we're getting. Unfortunately, they haven't put on the diagram what those voltages are, but I'm sure we'll get to the bottom of it one way or another. So these 2 capacitors here, that's in the outputs of the 3rd winding there for that positive and negative supply. So let's just see if we're getting an unregulated DC. Minus 26 volts, that looks okay. And positive 26 volts, that looks okay as well. And of course it will be jumping around a little bit, it's unregulated. And those 2 series transistors I looked at on the diagram, there they are there, and luckily they're annotated quite nicely on one of the layout diagrams. So we've got the emitters on that right hand pin of both. So if I go into this one here, let's get out of the way of the meter, we've got positive 14.6 volts there, and on the other one minus 14.5. So yes, we've got a plus and minus 14 volt supply for that analog circuitry. Looks like that's working okay. And switching to AC mode on my meter, let's just check the ripple there. Basically nothing on the negative rail and nothing on the positive rail. And looking for the main 5 volt supply, well, it looks like the 5 volt regulator is actually here mounted on that back panel. That'll be that TO3 package, and the output of it comes way up onto this board here, and this is it here. So going on to that, yeah, we've got 5.07 volts. So let's just check for any ripple, and it's pretty stable. So I think the DC supplies are working okay. So back onto the main analog side of the A to D converter, that main output here looks like it's QC from the simplified diagram, and that's coming from pin 9 from IC103. Well, let's just jump straight in and take a look and see what that's doing. So IC103, that's it down there, that's that 14 pin package there. So let's go on it in the first instance and check the supply voltages to it, and let's see what that output's doing. So pins 11 and 6, well, pin 11 is there, positive 12.3, that looks okay, and pin 6, if I can get to it, minus 6.4. And that would appear to be okay looking at the diagram, because there is a series resistor, so I think they've dropped down that negative voltage on purpose. But anyway, let's take a look at pin 9, because that is the output from that op amp, and that's it there, and it's all over the place. Yes, jumping around, and that would go along with what we're seeing on the display. It's just all over the place. But wait a minute. Remember, this is the A to D converter circuit. QC is actually, although it's driven from this op-amp, it's actually a digital signal. I think we've got some sort of multi-slope design here, so that's actually possibly a serial output, basically, that's part of the A to D converter, the analog side. So there will be a corresponding diagram for the digital side that takes this output here and basically converts it for the display. And if we look at QC on the scope, pin 9 of that op-amp, you can see that there is some sort of switching going on there. Whether that's meant to look like that or not too sure at this point in time. So we've looked at QC, which is part of the output side of the analog circuitry on that A to D. I think we need to go and look at the input side of the A to D and check some signals there. It was nice to see this. And looking at the schematic diagram for the digital side of the A to D, you can see that QC comes in here. So it is indeed a serial piece of data that's coming in to this NAND gate here, pins 1 and 2 on the top board. So here is the input switching schematic. You can see over here at the left hand side you've got the high and low bananas. And down here, this is a top-down view of the switches on the front of the unit. And you can see the pins are identified as 1 to 12, depending on what size the bank it is. And the columns there are A through to U. And that ties up with these annotations on the diagram. So you can see that the positive banana, the high, comes into 8C. So 8C would be that pin there, 8C. Well, tracing the signals through these input selection switches and range selection switches proven to be quite a chore, really. And I think some of them are in pretty bad state, because looking at the PCB, it looks like some of them have been soldered where they shouldn't have been. And also there is some residue in the top side. I don't know if it's like the switch has been heating up due to maybe the wrong voltage or something being put through some of the switches. I just think they're in pretty bad state. So what I'm actually going to do is jump forward. I'm going to bypass this range selection, input selection switches, and go straight to where the A to D starts. Up at the top left hand corner I've got WE, and I think that's the signal from the input selection network. And after all the current conversion, voltage conversion, resistance, ohms conversion to a unified signal, and I think that's it coming in here. Got a small filter here before it goes through, and it's selected or enabled via this FET here for the sampling to start or not. And I've managed to inject a signal in there. No idea what the range should be. I've got a couple of 10Ks there, so it's going to be something reasonably high, and maybe a volt or something like that. So I put in a 1 volt DC signal there, and I'm getting it through to the FET, and this gate on the FET is pulsing away, and that is it sampling the voltage there onto the drain, and I'm getting the drain active with the input signal every time the FET turns on. And that's about as far as I've got at the moment, because we start getting into this here. It's a very, very bespoke circuit there. Like I said, there's no A to D. It's all done in discrete electronics, etc. And as I said earlier, there is the QC that goes away off to the digital side. So somehow or other, this is sampling that voltage and converting it into a serial or a waveform of sorts, and driving QC. So injecting a signal in there doesn't change the display at all. So I think maybe the input switch circuitry is okay, although I've got my doubts. but I think there's maybe something else wrong here. But I think that'll do for a part 1 video. It's been a bit of a mission to get this far, and we'll maybe try and cover it in a part 2 video. So thanks for watching, and remember, you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.